Good morning.
Hey, Mark, good morning.
So the core meeting looks like it's going to go over again. I left, and we were maybe about two-thirds of the way through the list of people to go through. So I'll wait just a little bit here before we get started, but I suspect people will be joining late.
Sure. It's my
So
first
Randy,
time
have
joining.
you? Oh, excellent, excellent. Yeah, I was going to say I hadn't seen you in the meetings before. Are you a community member, Randy?
I work for Red Hat.
Do you? Okay, excellent,
Yeah,
excellent.
I'm in CE. I support SBR Ceph and SBR OCS, as well as all the cross collaboration for Ceph integrations. So,
Nice,
um,
nice.
do you know Michael Kidd or
Yeah.
Joe Quinn? Same team,
Yep.
my peers.
Excellent. Yeah, yeah. Michael has. I'm pretty sure he was actually there back in the ink tank days.
hmm
Um,
That's right.
so yeah. Well, very good, very good. Maybe while we wait for people, I'm always interested in hearing how things are going on that side. What kind of stuff are you guys running into these days?
Um, well, I spend the majority of my day just trying to stay afloat. I'm one of the only folks on the team that can take on, the L3 type OCS cases. Most of the time,
Okay.
it's OCP type issues, or just integration, or it's always something that's got like one tiny spin on Ceph, and it's mostly, OpenShift. And for that reason, I normally get punted those cases, so that keeps me pretty busy. IBM Cloud Paks is an abuser of our of our SLAs. So anytime
Sure.
they come around, it's like drop it, figure them out.
Yeah. Do you deal with very many performance issues on that side?
Mm, well, yeah, actually, now that I think about it, we've got a lot of folks who are just throwing anything and everything at OCS and then still has three devices.
Okay.
Concepts of tiering and understanding what will or will not get reconciled by the operator, which objects are, stateful, um, and what configs, have these specific static settings that it's appropriate time, or you would reach a scenario when it's appropriate to turn them off, scale them down to zero and say, don't do anything. I know what I'm doing. Do what you got to do from like a Ceph admin perspective, and then flip them back on and see what happens. A lot
Okay.
of trial and error.
So, semi recently, it's been a couple months now, but we kind of heard about people that want to run etcd on top of our RVD devices.
Try it.
Um, and that's a nasty use case because it's like
Oh yeah,
small, unaligned, synchronous sequential writes,
it's the
you know?
it's the old. Let's just have a virtualized control plane, put satellite director, cloud forms, and everything on Rev 3 nodes backed by Gluster, which just so happens to also be running the Mons and the whole virtualized control plane for Stack. Gluster hates that tiny I/O, so the minute you start a CDN sync, that would bring Gluster down. I mean, it's the same
Okay.
problem we're always fighting, and I think now with local storage having that native uh, association with hostname where pod can get scheduled is going to be very helpful for us to say, hey, it's not your root device anymore. Let's patch a local storage NVMe that's on your master because it should have had that to begin with anyway. And that
Yeah.
was the story that we were kind of telling when me and Michael Hackett synced up is we didn't do ourselves any favors by saying we support this IPI elevation because all that did was brought the problem back down to Ceph backed by spinners. What did the client expect? So ephemeral
Sure.
local on a compute node with SSDs would still be better if you trust the HA aspect that etcd brings to the table, and you're on top of
Sure.
it. If you want to back it by RBD because you say, hey, Cinder's going to work, it will work, but ramp up a workload, do a solid update, have it go crazy, OLM kick in, it's not going to be happy. Image registry
Yeah.
taking that amount
Yeah.
of IO. There's a bunch of stuff that happens, with just OLM in general.
Interesting. Interesting. One thing that I've been talking to Intel about lately, and I haven't seen them on the call recently, but they've been they've got something called OpenCAS. It used to be this proprietary caching layer that they had made, but now they've open sourced it, so it's kind of a competitor for DM Cache, sort of. But they've been doing a lot of benchmarking lately, looking at comparing those, and they really want to have something that can sit on the client side that is in front of RBD, so that you could do local caching as long as you're see that as an acceptable solution for your problem. But for some of these use cases, that might be a lot faster.
Huh. I'll have to scrub a BZ, but we had an instance where we had someone trying to do that on the LVM layer.
Okay. Okay.
As to front the whole, we don't have enough solid state, but the reality is how much solid state do we need? Let's see if this works. It was a topic that was briefly discussed, and I think it was shot back down in terms of we're not going to move that direction or support that model.
Sure.
I don't think we saw the value of the benefit in investing the time with the initial results that came out of
Yeah.
it. I
Yeah.
don't remember what Bugzilla that
Do you
was.
remember was it
Um,
LVM cache that they were using?
I remember it was specific to LVM, and it was an LVM cache thing, but I can't remember what about Ceph site was actually going to consume it. How it was going to get
Sure.
spun up and down. It was outside of our preview. So
Okay.
it would have
Okay.
been something native to LVM or something else. Let me see if I can find it.
Sure. Sure.
Throwing random keywords out of there. Come on. Of course, our Bugzilla is super fast.
But and from Intel's perspective, right, they just want to sell Optane drives. So that's their whole part of this is like they're working on the software piece, but they ultimately they want to be able to sell lots of Optane drives for client side caching for RBD. So that's
Mm-hmm.
that's where they're coming from. But legitimately, their stuff actually looks pretty good. I mean, their caching layer looked like it was in the test that they just ran. It looks like they were faster than LVM cache. So I'd be really interested to go back to those our developers that are working on and say, okay, is there anything that we did wrong here that should have been done differently, and do we make this? If we can't make this faster, because there's some way that we can use ideas and work together with Intel to make this work.
Mm-hmm.
All right, looks like we're starting to get people from Core. Maybe we'll get this thing off the ground. All right. Hey guys, so I think it's going to be a pretty short meeting today. There's not a whole lot on the agenda unless anyone has something. But we've got a couple of new PRs this week. One from Adam to make do small right, never do buffered writes. I had started writing up a review on this. I think my concern would be that right now we don't actually have the buffer cache enabled by default, and I think we probably need that to get rid of this. And after being burned a little bit when we turned on direct IO versus buffered IO at the BlueFS layer, I want us to be very, very sure that we know all of the unexpected consequences of doing something like this. So definitely we'd want benchmarks of data.
Yeah, I agree about the benchmarks, but I think you yourself and were saying that it's off by default, so the default behavior shouldn't change at least.
No, our cache, right? Like our
Our
maybe
Blue Store data cache. I thought this
yeah,
was
our
purely
Bluestore
about
data cache is off
block
by
good
default.
bytes. And doing not doing buffered IO to the IO. I thought it wasn't related to our cache. but maybe I'm misunderstanding that.
So my understanding is that and maybe I'm misthinking this, but that Adam's PR, he wants to not have AIO write do buffered writes to pollute the page cache. Like he doesn't want polluting the page cache because my understanding is his idea was that we already have our own buffer cache in BlueStore where we cache stuff. So why pollute the page cache when that then makes it so that like RocksDB stuff might get forced out of cache or whatever. Am I thinking about it right, Josh? Does that sound like what you?
I think he's also thinking about it as a correctness thing, like doing buffered IO and unbuffered IO at the same time isn't really recommended with the kernel in general. And the IO, you're generally supposed to use it with only direct IO. So it's unclear why we were kind of doing this buffered IO or had this buffered IO path as a possibility in the first place.
I assume it was to get it into the page cache because I remember Sage and I talked about this some years ago, but
yeah, but it's been off by default for so long now. That is, from Igor's comment, it sounded to me like it was making no change in practice with the default settings. It was only if you turned on this BlueFS buffered write option that it would change behavior.
Maybe I am missing that because I'm looking at the PR right now. I'm trying to look for like a conditional where if we have like this only happens if you have BlueFS, or sorry, if you have the BlueStore buffer.
Yeah, I guess it's the buffered property of the IO context.
Oh, I see. So if that's enabled in the IO context, then we do that code path. Okay.
Right.
Okay. Yeah. So in this case, it would only follow that if you already had the buffer cache enabled, and in that case, you would then want to do the direct IO rather than the buffered IO.
Exactly.
Okay. Yeah, I get it. That seems reasonable. Still think we should benchmark.
Yeah, it's always worth benchmarking. Actually, there is one other case where we set the flag as well, which is when we have the fadvise will need flag on the operation, although I'm not sure if we ever actually use that at a higher level.
We might, but I'm not confident enough to say that we do.
Now it appears we do in at least CLS FIFO for RGW and CLS RBD.
Okay. Yeah.
Okay, so yeah, probably might be worth changing that. So the patch changes that behavior for those operations then.
Yeah, I have a theory that back when a lot of this stuff got written, the thought was that we'd have like the page cache as kind of like we had like this kind of hierarchical cache structure, right? Where like we had the BlueStore cache for nodes that was supposed to be super fast. Then we were supposed to have like the RocksDB block cache that would be bigger and be encoded so that theoretically everything was smaller in it, and we'd be able to use that as like a secondary level cache. Then page cache is like a third level cache. And I wonder if maybe that's why this was kind of done that way.
Yeah, maybe. I think you're right. It would be worth benchmarking and seeing what's going on with it today.
Yeah.
There's been so many changes to the caching infrastructure since it was implemented.
Yeah. Honestly, if we can just switch to direct IO everywhere, like figure out why it's bad in the other cases, I'd really like to just get rid of buffer IO entirely. But
I agree.
We'll see. Yeah. All right. So let's see. Next. Initial support for CStore from Sam. I didn't give it the performance tag because it's probably not appropriate yet, but I wanted to add it in here. That's really exciting.
Yeah, that's fantastic. It's finally getting hooked up all the way through the stack.
Yeah, yeah. Okay, next, closed PRs. My little description change for Bluefus Buffer.io merged, it looks like, so that's good. Josh, I saw you commented on that it's not in the docs.
Yeah, in the Blue Store config reference, there's no documentation about the option, so you'd have to be looking at the source to know about it.
Do we want people to change this?
I think we might want to document it in terms of recommending that people disable swap. Or
Yeah, sure, that's right.
that could be maybe you don't need to document the particular option though. You're right.
I don't even know. I didn't check. Is this what level of option is this? Is this a user level option or is this a dev option?
I think it's advanced. Forget.
Yeah, I'm checking the PR right now. It is advanced. Sure. Okay. So yeah, we could certainly put something in the docs. Especially you're right about swap disabling swap. That's I think going to be really important.
Mm-hmm.
Okay. That lock was changed for BlueFS was reverted. Sorry, not BlueFS for Blue Store was reverted. So that's good. And also the other fix that I think probably wasn't actually a fix was closed. This mempool cache line optimization detection stuff that Loic has been working on. It looks like Smith Farm had written something that I think was related to QA for testing this, and that got merged. And then, I closed my old PR that had the BlueFS buffer.io documentation change and changed the onode map to uh, uh, tree structure instead, since Ronan wants to try playing around with the hash specialization or the onode map when using an order map, see if that works better. So that'll be a fun little project for him to work on when he has time. Let's see. Updated RGW compression bypass. Casey reviewed that further. I didn't really pay too much attention to what he's talking about there, but looks like it's still actively being looked at. Gabby, your looks like you've been making more fixes to your allocation work.
Sorry, come again?
Oh, it looks like you've been making more fixes for your.
Yeah, but it's just trying to. I'm just testing and trying to fix things as I go, but it's not changing anything about performance.
I've lost you.
So I'm saying I'm making some changes around how these things start, open, close, and such, but nothing about the main algorithm. So the performance are the same.
Awesome. Awesome. All right. Good luck. I know this can be trying getting through all those tests. All right. Last updated one here. This Crimson OSD's client request parallelism PR. It looks like that got rebased. I'm very curious to see how well that one works in performance testing. Otherwise, a lot of stuff has no movement. I actually didn't make it through the whole list. Unfortunately, I didn't have time to finish up this morning, but I think most of this other stuff is probably still just stale, unless occasionally we see updates, but a lot of times it stays stale. So anyway, Did I miss any PRs anyone's working on? All right. So the only discussion topic I have is that I've just got a couple of updates for the OpenMap bench work that I had mentioned last week. Gabby, some of this is for you. So I went back and I looked at. So for people that haven't seen these before, I'll just link the spreadsheet into the chat window here. And Gabby had noticed in these tests that last week that we saw like a huge performance improvement between Luminous and Nautilus in a couple of these tests. Specifically, the set keys and the remove tests saw really dramatic performance improvements when going from Luminous to Nautilus. These numbers are in seconds, so basically between like 5 and even up to like 15 times or higher, maybe even yet times faster. So, and he was worried about it because that's a big change. So in the third tab here, I started going back and trying to look at different versions of master in that time period. And I don't have everything in this table yet, and I still have a lot of tests to do. But the gist of it is that we're seeing, to me, what looks like not a single commit making things faster, but perhaps multiple commits between Luminous and Nautilus that perhaps are having an effect. It's hard because the version of Luminous I tested had a bunch of backports already done to it. And when I went back in time to these point-in-time snapshots of master, one, it was super hard to compile these on CentOS 8. It was not happy. I had to do a lot of screwing around to get stuff to compile right. I also had to backport the OMAP bench to work with intermediate versions of the code as it changed, since that API, the Object Store API, had changed some. But I was able to get it to work, and I saw that set keys was faster, but not as fast as Nautilus in these kind of intermediate versions of specific PRs that Sage did that reduced flushing behavior. And I had noticed as I was doing these with wall clock profiling that flushing really seems like it's the key to this story as to why it's so much faster. In Luminous, in like set keys, we're spending a huge amount of time in the KV sync thread just doing, I think it's sync file range, if I remember right. Like 60% of the time in the KV sync thread was spent just doing that. And in Nautilus, we don't see sync file range at all, if I remember right. It's I think we're doing fdata sync, and surprisingly, that seems to be much faster. Not really exactly what I would have expected, but we also, I believe, reduced the amount of flushing and syncing that we're doing, specifically for OMAP. So I believe that the story will become more clear as more stuff comes to light, but that's kind of what we're seeing now. Interestingly, though, the remove performance didn't change. It was more or less what it was in Luminous. So something else seems to have improved that in Nautilus. It doesn't seem to be the same effect, or at least not all of the same effect. So lots of interesting questions still exist. But that's what I see right now. Kind of separately, I was looking at buffered versus direct I/O and why that is so much better in buffered for like OMAP get and a couple of other cases. Remove actually is one of them. And with wall clock profiling there, I saw that with direct I/O, we are indeed going back and doing a bunch of reads on disk in prefetch that we don't do when using buffered I/O. The strange thing is that both should be reading from the RocksDB block cache. We already knew that. This is just more further confirmation that in the well clock profiles, we do not see that happening. We instead see us, instead of reading from cache, we see us reading from disk. And it's really, really clear. So, still don't know why, but it's just kind of more fuel to the fire that that for some reason, things that I would have expected us to read from cache in those scenarios were not. And that's all I've got. Anyone have any questions on any of the stuff?
Your testing is on all downstream builds?
Upstream.
Upstream?
This is literally like pulling stuff out of old master, upstream
Yeah.
master, like intermediate commits. So yeah, it's all upstream. Though we do have evidence that disabling or re-enabling buffered I/O, BlueFS buffered I/O, and then disabling swap on the system seems to work much better for people than using direct I/O. We had disabled BlueFS buffered I/O like a year ago because of some internal testing on, I believe, on downstream that showed that we were seeing really bad swap behavior with RGW, with OSDs that had RGW targeting them. When that was essentially just causing everything to like fall over. It looked like the actual OSD processes were getting swapped out possibly, and everything was super slow and problematic. When we switched to direct I/O, that didn't happen, but it turns out that we didn't realize when we switched to direct I/O that was causing certain like collection listing and OMAP performance to really degrade badly. It didn't show up in any of our performance testing at the time. So people started really noticing that when they were doing things like deleting PGs, I believe, and a couple other scenarios. So now the recommendation we have is leave BlueFS buffered I/O on, and that's the default again. Now back to that being the default, but simultaneously disable swap.
Is this the result of the Bloomberg issue?
This is a public meeting, so we don't talk about it. But it was a customer that ultimately resulted in a lot of this work done.
I did look who was here. I just didn't realize it was being recorded again.
Yeah, it's being recorded, but that's okay. I'll just mention not to share this one, so no worries. Okay, so that's all I've got, guys. Anyone else have anything they want to bring up? Oh, Adam's here.
Hi guys, I was on another meeting, so I just joined.
No worries, Adam.
I have no way to know what you were talking about, Mark, until I rewatched the meeting, which I will not. So
yeah, no worries. I was just talking about this OMAP bench stuff that I had some more updates for it.
I've actually got about myself, but maybe if not Adam's here, you can talk about the PR with the buffering.
Yep. We talked about it a little bit earlier, Adam.
About buffering I/O or what? But I'm still not in the context.
Adam, your PR for changing do small, write small to never do buffered writes.
Oh yes, that is something that I think we should do. It cleans me the ability to modify the block device interface a bit more, and I also think that it's just by mistake that it doesn't really bring us anything useful.
I have a suspicion that Sage did it back then because he was at the time he was thinking a lot about things in terms of like multi-level caches. Like he wanted the O node cache in Blue Store to be a high-level fast cache, with like the Rocksdb Black cache being a slower but more dense cache underneath it, and then potentially the page cache sitting under that with like that being kind of like the third level cache that can be shared between different processes and things. So I wonder, it might have been a mistake, but he also might have been thinking about like it being a secondary, the page cache being like a secondary cache underneath the buffer cache in Blue Store.
I don't know. I mean, we are using that way. I mean, AIO write with dependence on whether we cache it or not, only in do write small. In other cases, we don't do that at all. So that I still leave some room for thinking that maybe we wanted to make a behavior that if we do write small and only fill a sector in half or something, we expect to add it soon. So we will read it soon. It kind of makes sense, but it also makes sense on the level that we could cache that remaining data ourselves, and then when reading, use our data read, not go to page cache. It's like we did not really decide what we want to do. It's like split logic. So that's I thought that maybe try to go straight and clean that wiggle room will be better.
We should test and verify it doesn't cause any strange like corner case issues like when we disabled BlueFS buffered IO, like just to make sure that there's nothing weird that we don't expect. But in general, I agree with you. I think.
Yes, I will. I did not test that yet fully, and I intend to test that using a basic small unit for testing, smaller than allocation unit. So I will be spamming a lot of really small writes, and that's the possibly a place that I can see a difference, because otherwise there will be no difference at all.
Josh and I think both agreed with each other that it would be really nice in general if we can fix whatever's going on with RocksDB to just get rid of buffered IO all over. Just make everything direct IO.
I think Josh is gone.
Yeah, he left.
But yes, I agree. I would prefer to go for direct IO in all cases if we're doing any buffering ourselves. So for Blue Store, it might make some sense to use buffered IO, really, but maybe even there so much if we properly verify finally that we're using a block cache as we should use it.
Yeah. Cool. Well, yeah, I think that's all I've got this week, guys. Anyone want to bring up anything else?
One question I don't really understand. When we say buffer IO, is it specifically for spinning drive or it's also for SSD? Because there's a huge difference between them in the need for buffering, right? SSDs are sometimes even better without any buffering, while spinning drives buffering is the only way you could get any meaningful IOPS.
I'm sorry, I will ask who was just talking because no icon was blinking. Gabby, is that you?
Yeah, sorry, it's me.
It's your new mic. I'm not accustomed to your new mic, sorry.
Yeah, it's really annoying, but it's wireless, so I decided to join the future and go wireless. So did you get a question?
Yes, we do not differentiate turning on and off of buffered IO depending on the type of device you are based on. I did not see such kind of recommendations, and I didn't hear anyone talking about it that way. We either decide to make it buffered on the page cache level, and then we make it buffered, or we buffer it ourselves and we just make it using direct interface and buffering ourselves. Why do you think?
When we buffer, it's just a write or it's also reads?
We buffer reads also. We keep in Blue Store block cache any data we read always. We have an option to maybe also put there a data during write for some reason. We can that part is optional, but caching on read is mandatory.
So that's the thing. So if SSD, there is always a good reason to buffer write because of write amplification. If you could do proper read, sometimes it's even better just to go directly each time and don't bother too much with buffering. I mean, some of these SSDs, they can do like hundreds of thousands of IOPS.
Okay, Gabi, I will stop you there because I don't understand. What do you think by it makes sense to buffer writes?
I'm saying when you say buffer IO for read, block device, I'm completely with you. SSDs, it's not the most, especially when you're talking about multi-levels read buffering, right? I mean, if it was just one specific buffer read that we control, yeah, sure, go for it. But once you have multiple players trying to buffer read, and we're only talking about SSDs, I mean, I would try to do without buffer read for SSDs, just because we have multi-levels of caching.
We're trying to head in that direction, Gabby. The problem we have right now is that for some really strange reason, it doesn't appear that if we have like an O node miss, it looks like if we I don't know if it's an O node miss exactly. It's more like if we have a miss for like OMAP data when you're looking at an O node or something or something else, right? Like a RGW object, that we don't read it from the block cache like we should, especially during iteration for some reason. I don't understand why, but we end up.
Does cache it, right? It is cached inside RockDB cache.
That's the problem, is that for some reason it doesn't look like it's reading from the block cache. Those blocks don't seem to be getting read the way that we would expect them to from the block cache. Instead, it's like going into a prefetch step and rereading from the disk. And it's doing that, like, even as we like reiterate over and over again, it will like go refetch that same block from the disk over and over again, leading to like huge read amplification.
Do we have an option for RocksDB to say, don't trust cache, always go to drive?
Well, I mean, you could, but the problem we have, right, is that if you're like iterating over a collection and you're always reiterating from the same point, looking for something in the collection, which is apparently what it seemed like we were doing, especially in older versions where before Igor's some of his fixes, it would like just keep rereading the same block over and over again from disk. It was like awful.
No, of course that thing is terrible, but doesn't RockDB take care for this? I would expect them to be able to handle this thing because people are using this thing, right?
So it might be a bug.
RocksDB is a specific scenario.
RocksDB typically uses the page cache, though. Usually it's doing buffered reads, and it uses the page cache as like a secondary cache for the block cache. And by doing that, even if you're like rereading the same block over and over again, if it ends up in the page cache, it doesn't matter really. I mean, sort of. It's not great, but that's how we get around this right now. Is that we had to turn BlueFS buffered IO back on so that those block reads would come from page cache rather than from disk.
So we are trying to solve a bug in RocksDB code by introducing yet another cache layer? Maybe we should
We don't
try
know.
and find why
Yeah, we're not
RocksDB
sure,
is in
Gabby.
such a way.
This is only the suspicion that we have because it's not behaving the way that we expect. So
But
we're trying to.
can we produce a test showing how many times RocksDB accessed a drive for stuff which should be in cache?
I think Adam has some stuff that he's written that will let us look at the hit rates in the RocksDB
Yes, I
block
had
cache.
that. I have to rebase it to master again, and maybe finally we'll get merged.
I mean, if we can prove that RocksDB is reading from this stuff which is in cache, that probably means that they are using some options. There are some options to bypass cache, right? I mean, in every system, in every caching system, there's an option say don't trust cache. There's options, or maybe there's an indication causing RocksDB to suspect that the cache is not up to date, that there was some change which is not reflected in the cache. If we could find what is this thing causing RocksDB to mistrust the cache, maybe you can just fix that issue instead of doing double caching.
Yeah, I think that's the long-term goal, Gabby, is that if we can do that, then we might be able to go back and disable buffered IO again and just go straight back to direct IO without the performance hit.
Yes, I concur. That's the what thing I would like to see. We just make block cache work perfectly fine, and we disabled buffered IO, and we control fully the memory we are using for OSD.
Yep.
Do we know what option causes RocksDB? Sorry, in what cases RocksDB bypasses read cache?
We see the effect of it primarily, I think, when we're doing like iteration with like OMAP. That seems to be a really common case. In that spreadsheet that I linked, if you look at the second tab, that's like the 500K/20 tests. Even if you look at like the 16 gigabyte numbers, that's where there should be plenty of block cache for this. Everything should fit in the block cache. Yet when we switch from buffered to direct IO for like OMAP get, it was very slow. Although the iteration was faster, I take that back. The iteration seek to first and lower bound was actually fast in that case. It was just get that was slow and delete that was slow, or remove that was slow.
Okay, just one more question. When you say direct IO, do you mean RocksDB direct IO or do you mean our own direct IO? It's an
BlueFS. So RocksDB is actually running on top of BlueFS as like a virtual file system.
No, but when you say direct IO, do you set direct IO option for RocksDB or for BlueFS?
For BlueFS.
Because RocksDB also have an option for direct IO, right? So they have direct IO option to bypass the operating system cache.
No, it's irrelevant because that option only tells how to operate its port. But we are having our own file system port, so those options do not even matter for us.
I'm just now trying to read in RocksDB pages what are they doing and what would cause them to bypass the OS page cache. Okay, so we definitely need to try and understand this behavior, but it should be something documented. I would expect that such thing as when to bypass the OS cache, when to mistrust OS cache, or what kind of logic causes RocksDB to suspect that the cache is invalidated. Do we have an option to invalidate a cache? Does any of these things under control?
When you
No,
say
we don't. You mean
Go ahead.
our block cache invalidate? No, we don't have a command to invalidate block cache we provide for RocksDB.
But no, I'm saying there's something causing RocksDB to mistrust the cache, or I'd expect so. I mean, in some cases, just think about.
Gabi, we don't know. We don't know if the RocksDB mistrusts the cache or just using it incorrectly. From what I can see, when I observed it in detail, I've seen that RocksDB tended to request a lot of entries from cache that were never put there. It was like a different pattern of a key that they were trying to retrieve, and of course they weren't there. So maybe there's just an error.
That is normal, right? I mean, usually what I would do in a caching scenario, I would always start by searching the cache, and if it's not there, I will go to the disk. If I don't maintain history, what I put in a cache and what is not, the simplest thing is always go first to the cache, and if it's not, go to the disk. But you are saying that the data exists in cache. We know that it's in a buffer cache, but RocksDB still goes to the disk. So it doesn't ask if this thing is in cache. Is there some reason for them to say, we don't trust the cache, we don't expect? Maybe it's an optimization. When they don't expect stuff to be in cache, then they don't go there. Or maybe it's something automatic. After they had that many cache misses, they would stop going to the cache because going to the cache introduced some extra hope that they want to avoid.
Gabby, I put a link in the chat window. This is like a walkthrough of the code that Adam and I were doing a couple weeks ago, I guess, or maybe longer. Holy smokes. Back in March, I guess. So possibly maybe that will be, if you're interested in looking at it, that might be a good place to kind of see the flow of how the code works.
Okay. And since Adam works in my time zone, I will maybe try and schedule one-on-one with Adam and try to better understand this scenario.
Yes, Gabi, I would really love to. I mean, but it's not that I know the answers. I'm also just searching almost half blind through RocksDB code and the effects I see in the logs. So I would gladly debug that with you. Maybe we'll find some serious problem.
I'm looking for the answer. Yes, I'm still trying to start from the question. Once we have the questions, then we can go search for the answers.
Yeah, I think the next step in my mind is we need to see just if what the block cache is actually doing. Like, are we actually fetching stuff from it, and how often are we actually doing the reads from disk, and then from there we might be able to actually start instrumenting the cache itself to tell us why it's making decisions the way it is.
Yeah. Okay. Yeah, that sounds like a start.
All right.
Is it again just us? No, there are some more people.
Sorry, Gary, what were you saying?
No, I was asking if it's again just the three of us.
Oh, no, we've still got Randy. We didn't steer him up yet.
And Matthias.
Yeah. Hello.
I can drop
you. No, it's not about that. We usually talk so long on this talk that everyone gets disinterested and goes away. But it's not like it's a private one.
I'm part of the COVID generation now. I'm just trying to find friends that aren't my kids.
I hear you. All right, well, I'm actually going to wrap up early today, guys, because I want to go have lunch and eat. So any last minute things anyone wants to bring up?
I'm good.
No, I would just like to... sorry, please go on.
Just that BZ I threw in the chat, just something to keep in the back of your mind if you ever hit a bucket with millions of objects. If it has a soft quota tied to it, we saw a recent issue, and it's present in master right now, where it will go and still do a list object or list buckets against the bucket with millions of objects on a simple get, even when it's not explicitly called because of the quota. And that was generating a significant amount of IO on the bucket index pool for a customer we had recently.
Well, I will take a look, but from what I scanned, I couldn't understand anything, so I need more time.
Sure, no problem.
And Gabby, did you have something too that you wanted to bring up?
No.
I would just like to
it's going to keep me busy for the foreseeable future.
Okay, I would just like to signal that I will be touching block device interface and straightened up dependencies between being direct I/O and buffered and asynchronous. I just want to make it always asynchronous is never buffered, and the other modes might and might not be buffered. With addition that possibly I will add an API call to sync write that is different than write. I mean, synchronize regions to disk, make sure that they land on disk being different than write, because currently we made it so, the implementation at least is, that write, unbuffered write always tries to make sure that data goes to disk. Buffered write makes sure that always data goes to disk. So there's no possibility to spam small writes to the device and then at some other time make it flush. Yeah, that's stemmed from my problems with performance with BlueFS and buffered IO that was hit. So yeah.
Sounds good, Adam. That sounds excellent. I think we need to do lots of testing, but I think it sounds like a good plan.
Yeah, thanks.
All right. Well then, have a great week, everyone. See you next week.
Thank you. Bye.
Bye.
Thank you, guys.
Bye.
See you later. Also, Matthias and Randy, visit us next week.
Yes.
If time permits.
Sounds good. Bye, everyone.